Not be done, that's okay. This is a little bit of a review, and I want to be able to at least get us started today. Okay? So what we're looking at here, majority of this is just kind of like a pulling together of all the probability rules that we've used so far with our normal curve. So for part A, it says, what is the probability that a randomly selected rat will weigh more than 940? You have a mean. You have a standard deviation. What model are you using? Normal model, so normal CDF. So for this guy, you should walk away with 13.57%, 0.1357. Gotta love it how this textbook is anything but consistent. Okay, questions on that one? 0.1357, please do. I prefer that so much more. Yeah, this textbook irritates me because they flip-flop. Yes. Because they're saying more than 940 grams, they have converted it and found the z-score that matches with it. Okay? Because remember, and you guys have to remember this, when you're doing one of these problems, the order for your work is going to go like this. You're going to talk about what the model is. It's a normal model where the mean, what is the mean? 775. Standard deviation. Okay, so you describe your distribution. Then you want to make sure that you're talking about finding your z-score. So you have to show me the formula for your z-score, which is the observed, so that's 940, minus the expected, 775, divided by the standard deviation, which is 150. That's where the 1.1 comes from. You have to, in the calculations of this, show me what your z-score is. It's been a while since we've done a problem that was as straightforward and simple as that, so I get if you've forgotten it, but they are extremely critical when it comes to the AP exam that they want to see your test statistic whenever you're using any distribution. Okay? So again, with that being stated, draw, label, and shade. For this guy, basically you're saying, okay, I know my average is 775, so 700 is a little bit to the left, 900 is a little bit to the right, and if you have done this much, that's describing your normal model, so you can go ahead and find the probability 0.489 about. Okay? And we skipped C because C is picking up with these Bernoulli distributions where we're saying, okay, success or failure. But this one's saying I'm going to run 10 trials. I want 4 successes. That's not geometric. That's what we're going to be talking about later today. That's actually called our binomial distribution. Sammy, guess what we're doing in class tomorrow? Binomial distribution. Poor Sebby, he has me every single day. All right, so now we're talking about space. If a house has 3 bedrooms, what is the mean and standard deviation? So, is this 3x or x plus x plus x? X plus x plus x, because not every bedroom is required to be the exact same size. Okay? Kind of understand the reasoning behind that, because that's one thing that's been causing folks a lot of struggles. Okay? So that means when we find our expected value, it should be 900 feet squared. Standard deviation should be 11. I'm sorry. Oh, is it 200? Do I not know how to math? No. Have an average area of 300 square feet.
Keep reading.
I don't read good, apparently. Okay. So bedrooms have a mean of 200, so yes. So this should be 3 times 200, so it should be 600 feet squared. Because I just pulled it from wrong spot for one problem. Should have leave me alone. Don't be so mean. Yes, I did the standard deviation right, though. Did you get 112.58 feet squared? Okay. Again, please, please, please keep the difference between x plus x plus x separate from 3x. Okay? Now, a total area of a 3-bedroom house has an average of 2,000 square feet, standard deviation of 225. What is the average and standard deviation for the living area after the bedrooms and kitchen are excluded? So if I'm going to talk about this and I want to represent it with the model, if I were to talk about the whole house is made up of what? 3 bedrooms, a kitchen, and whatever's else is out there. So I have X1, X2, X3, 3 bedrooms. So these are each a bedroom. I have Y, which is my kitchen. And Z ain't got no clue, it's everything else. So if I wanted to write an equation that represented the rest of the house, I would say Z is the whole house minus my X's minus my kitchen. You understand what I'm talking about? So this is the formula that I would use to set up my mean and expected standard deviation. So my expected value should be 1,100 feet squared, or square feet, however you want to say it. Square feet. All right, anything else? Are we okay on that one? Standard deviation, just like what I said, I'm going to be talking about, and you can write this in several different ways. Here you can see that I've got 225, which was the whole house. Bedroom, 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 kitchen, random other stuff. Okay? And you really do need to do it this way. What are you? I'm going to throw my shoe at you. So am I, apparently. All right, so, and when I was writing that equation on the board, I was kind of leading you in the wrong direction. So let me write this out for you. You know, with the actual correct numbers. All right, so for this, we're going to have the bedrooms be X, where the expected value of the bedroom, what was the expected for the bedroom, guys? 200. And the standard deviation of the bedroom is? Okay, so then we had the kitchen, which I'm letting that be Y. 300 for that guy. And thank you. Okay, and what we're doing here is we're saying the whole house is made up of 3 bedrooms, a kitchen, and some other stuff. Now, the way our distributions work is I have to be able to set up an equation like this, because the house itself depends upon the size of the bedrooms, the size of the kitchen, and the size of everything else. If I solved this for the size of everything else, then you're saying that this depends upon everything else. This is my dependent variable. These guys are my independents. Okay? So when I'm talking about the expected value of the house, it's the expected value of the 3 bedrooms, the expected value of the kitchen, expected value of the rest. So they tell me that the total has an average of 2,000. We know each of the bedrooms, so I'm going to say 3 times 200. Huh? Oh, no. And then I've got the kitchen, and I have other stuff. So when I go to solve this, you get that expected value of the other stuff is 1,100 square feet. When we're talking about the standard deviation of the whole house, and again, it's about which one are the independent, which one are the dependent variables. You typically don't say, hey, guess what? My house is going to be 2,000 square feet. Now I'm going to squish everything else around into it. I wish that worked. It doesn't. I've been trying to do that. It's not working. So what we have here is we're going to have standard deviation is the square root of the variance of each of these. So I'm going to say the standard deviation of x squared, standard deviation of x squared, standard deviation of x squared, standard deviation of y and squared and whatever's left. So putting these things in, the standard deviation of this one was 225 feet. So that's going to be, what is this? The square root of 3 of 65 squares, of 45 squared, and something else squared. So far, so good? Then to solve this, I would obviously just square both sides. This is going to be a big number. So I'm going to take 225 squared. So 50625 equals 3 times 65 squared. 12675 plus 45 squared. 2025 plus something squared. So that means my something squared because the 5 fell off. I inserted a number. You have an insert key. So right above your delete is your insert key. And you just know that it's going to always put it to the left of wherever your cursor is. Did I just like explode knowledge upon you? For a minute. So we're at 35925. And the square root of that puppy is not as cool as my puppy. So the standard deviation of that is 189.5. Not what I wrote. Oh, because I did the wrong numbers. Yeah. Okay. You still didn't get that? Are my numbers okay? Is that what you got, Luke?
No, I did it.
Okay.
How'd you do it? I just put them all on the square root. 225 put it on the square root.
Okay.
I didn't do that.
Well, that looks right.
You didn't get that?
We did this for 65 squared.
So 65 squared plus 65 squared plus 65 squared plus 45 squared. But then there's going to be something else under there. So if I square this side, so I'm going to say 225 squared minus that. And then I'm going to take the square root of that. Because, you know, I squared the 225, right? And so I had this equation by itself. So I solved for whatever was at the end. And then I took the square root. Was your hand up?
No, it's okay.
All right, for number 3A, what's a probability that you listened to a CD? 0.46 something. Okay. Now on B, is that an and, a given, or an or? That is a given. What are you given? They listen to music on a CD. So that probability there should be 0.4667. Okay. So if I am looking at this last question where it says, does it appear that these events are independent? Justify your answer. Here I have digital given CD. I have probability of CD. Can I just compare these two numbers? But they're both got CD in them. It's not about the given. It's the first thing, right? No, this is the given.
Oh, yeah, you're right.
Okay. So the first piece has to match. So I could say the probability of digital given a CD versus the probability of digital total. But that first piece has to match. You see here I've got probability of digital given a CD is not the same thing as the probability of digital. If you wanted to use probability of digital given CD, then you'd need to compare it against the probability of either just digital or digital without a CD. Okay? All of these different things are things you could have compared to get the same answer. You just need to be really careful because a lot of people would have said, oh, hey, look, 46.2, 46.7. That's within 2%. That's really close. They should be independent. But that's because you're comparing the wrong fractions. Okay? And our last one here. What is the probability that you win $20 3 times in a row? Yeah, not too hot, huh? So 0.125 cubed, because you're basically saying, I win 200, I win 200, I win 200. Sound like a broken record. Okay. If you played the game 10 times, how much money would you expect to win or to lose? Do you think you're going to win or do you think you're going to lose? You think you're going to lose? What is my expected value for, or what are my outcomes? Break even, lose $5, get 15. Everybody understand what I'm talking about? What's the probability I break even? 0.5, Rhea. Yes, 0.5. What is the probability that you win 15? 1 out of 8 or 0.125. What's the probability that you lose everything? 3 over 8. So, if I'm looking at combining 10 separate games, in order to do this, you need to first calculate the expected value of each game. What I'm seeing a lot of people doing is you're leaving off that idea of 0. 0 has an expected value of, or has a probability of 0.5. 15, 0.125, negative 5, 0.375. So for one game, I have the expected winnings of nothing. So that means if that's one game, if I already tie together 10 games, I should walk away expecting nothing. And your favorite type of question. You lose 4 times in a row. Gonna roll again because you're due a win. No, why not? Memory list property. What's true about each of these events? They don't affect each other. They're independent. Unfortunately, this is what a lot of people with gambling problems think. I just got to play one more game. I'm due a win. And you lose your house. And your job. And your wife. And your husband. And your kids. It's just bad. You don't want to do that. Okay? So please, please, please don't become gambling addicts. It is not smart. Okay? But it is fun. Careful. It's exciting when you win. It totally stinks when you lose.
So get out while you're up.
Quit when you're ahead. Or quit if you're behind. Or just quit playing.
So if you win big, get out.
And if you've lost big several times in a row, get out. All right.
No, but that's the thing. People win big multiple times. Like first time they win big, they're like, oh, I can do it again.
Somebody wins the Powerball. Somebody wins the Powerball. Someone's got to win.
But that's different.
No, it's not.
$2.
All right. Okay, guys. I have a feeling not many people probably did the homework because we didn't get through the entire lesson. So I really cannot recommend this enough. You need to go back and look at these answers. Okay, a lot of these are very similar to what we had done in class, but with basketball instead. Lots of basketball problems. Who's Bernoulli? Bernoulli is the guy that determined a lot of this stuff. Yes, sir.
Question about homework.
Sure.
The models that they asked you to do, I think it was on 35.
Yes, sir.
Question C.
Uh-huh.
They talked about how, that's what I was, the
Table.
Yeah, okay. I didn't do that.
You can do it vertical, you can do it horizontal. Sometimes it's easier to do it vertical because you're like writing out this stuff and you don't know how much space it's going to take. But the same thing was true for problem number 5. Only for problem number 5,
Weren't they technically the same? Because the probability
Yeah.
never changed.
yeah. Okay, so here. So what we talked about that we finished up a little bit earlier was one specific probability model. What were we dealing with? Geometric, yes. Geometric started with our idea of a Bernoulli model, this type of an idea. The binomial, and I know it's frustrating because they sound so much like Bernoulli, binomial. Well, a binomial is Bernoulli, just like a geometric is Bernoulli. But what the heck is the difference between all of these? A binomial model says that no matter what, I'm going to do a set number of trials. I'm going to do it 10 times. I'm going to play 100 times. Whatever it is. I have no idea what that was. No matter what, I have a set number of trials, and I'm just going to count within that how many successes I have. Like, okay, you know what? I'm going to the casino with $50 in my pocket. I'm going to play however many games I can buy with $50. And I'm going to walk away when I'm done with whatever I've won, whatever I've lost. Okay? Set fixed values. Binomial is different than geometric because geometric was very specific about geometric. So geometric is go until, right? Geometric, you're going until you find a success. Binomial, nope. No matter what you're doing it this many times, you're going to count how many successes you've got. Boom. You're done. So for binomial, what you need to understand is that you have a fixed number of trials. And when we're talking about the binomial model, with that we have to kind of extend what it is that we're talking about. We still have the probability of success, but we also need to incorporate into that distribution how many times am I going to do this. So if you want to think geometric, go until. Binomial, n is set. Okay, geometric doesn't have an n in it. Binomial does. Yes?
So n would just be like 15 times.
N would be 15. And if you're counting the number of heads that you have, let's say we wanted to find the probability that you had exactly 6 heads and that 15 flips. And that would be binomial. Rather than geometric would say, hey, take this coin, flip it until you get a heads. Okay? Now, binomial and geometric are extremely similar except for one little thing. They are both Bernoulli. They both require independence. Hang on a second. All right, so each of these have the same general requirements, like I was saying. You have you have Bernoulli, success or failure, independence, and the probability of success has to stay the same. But instead of bits, here we're talking bins. T was we're counting trials. For this case, B is still binary, I is still independent, but we have an N because we're looking for a fixed number of trials. Instead of go until, now we have a fixed number of trials, and it's got to be fixed in advance. You can't say, I'm going to go, if you haven't hit like a success by the 3rd time, go until you have 10. You're not mixing this stuff up. Okay? So binomial, N is set. Geometric, go until. You don't have a set number. Okay? You need to keep that straight. And what's really, really nice about binomial and geometric is this is the one situation in the whole entire class that the AP grading rubrics allow for calc speak. But when you're talking about the distribution, it's binomial. Oh, you don't have to tell the whole thing. You need to talk about how many trials it is, and you have to tell me N equals and P equals. Okay? So let's kind of see what this looks like. Just like with the geometric, we could calculate expected value, we could calculate standard deviation. We have the same thing with the binomial model. It does involve this. I'm just getting so excited for you, Sebi, because you're doing this tomorrow. Poor kid. Taking functions trig and this class at the same time. But that binomial model that you talked about in Algebra 2 trig, functions trig, maybe even calculus, it comes into play here. And the reason for it is if I have, for example, I'm rolling a die 10 times, and I want to find the probability of getting at least exactly 3 heads, think of all the different ways that can occur. Could be 1, 2, 3, 1, 3, 5, 2, 4, 8, all of these different selections. Order is not important, but where they were is. And so that's where we use our combinatorics here. And in your calculator, that's found by doing NCK. Hey guys, guess what? I'm not going to ask you to write this stuff down. Okay, your calculator will do this for you. But in case you don't remember, NCK, which is also written as N over K, not a fraction. I really have every time I draw it, I always want to draw a fraction line in between. Not a fraction. It says out of N, we're going to choose K. Recalling that the factorial symbol is not N. No? Not even a chuckle? Ha ha ha. It's not an exclamation point when you are in math class. It's a factorial. Get it? Come on. And again, order is not important for this because it's the idea of, hey, we're gathering 50 people to select a possibility of being on a jury. It doesn't matter if you're the first juror chosen or the last juror chosen, you still got to sit. Okay? So this is what works when we're talking about selecting from a group. This is built into my formulas. Okay, so here we go. This is stuff you do need. N is the number of trials. That's my set value. I'm going to do it this many times no matter what. P is my probability of success. Remember, because these are independent events, that probability should stay consistent throughout. Or if we're drawing without replacement, we have to have less than 10%. Okay, that kind of helps maintain my probability of success within a reasonable window. And I don't care if you use Q for failure or 1 minus P for just saying, hey, it's not a success. Nobody really minds one way or the other, whichever one you want to do. The general way that people will write it is 1 minus P, just, so if you've never seen Q before, it doesn't rock your world. You get one more piece from this, and that is X. Your X here represents the number of successes we're looking for out of that set number of trials. And yes?
Number we're looking for, the number we get.
For example, if I was saying I'm going to flip a coin 10 times, I want to know what the probability of getting exactly 3 heads is. N would be 10, X would be 3. Right. And so, to answer that question, it really kind of depends upon how the problem's set up. But N is always the total number that you're looking at, and X is whatever your success that you're interested in. Okay? We get a couple of formulas. We get the probability, and this is red, because X is the number of successes in N trials. This is saying the probability of getting little x successes is written as NCX, or just like I've got up here, N, but this time over X. P to the X, because this is my successes, the number of successes. Q to the N minus X, because that's the number of failures. Together, you have a total of N trials. X successes, the other failures. And that NCX just says, hey, all the different ways that those specific combinations can be made. Okay? We have our expected value and our standard deviation. Dude, if there's a 20% chance of success and I'm doing it 10 times, I can expect 2 successes. Nice and easy. The standard deviation here is root NPQ. Yay? No? You guys look so happy to be here on this glorious Tuesday. No? You happy it's Tuesday? That's something. Hey, wait a minute. We have this week and next week, and then we get spring break. Keep that in focus. She's like, wait a minute, this week and next week? Yes. Okay. So let's try some problems. Y'all got problems? Let's try some math problems. Really lame. I know. Hey, girlfriend, I got problems too. It's all okay. We could only solve the math ones in here, though. True that. So I'm also going to be focusing here on what it is that you need to show me for a problem like this. You got to be real careful. Okay. So there's one thing that I have here. What is it that they've given me? 1 probability. 0.8. Everybody okay with that? Probability is a 0.8. Now, to answer any of these questions, we need to start with making sure it fits our assumptions and conditions. So, what do I need? Binary. So, is it binary? Yep. Either you hit the bullseye or not. What's my next thing? Independent. What do you think? We're told independent. Good. What else? But we're going to get to that in a second. But what stays consistent between both of them? Successes. So success, constant at okay? So far, so good. Now, what you've got to be careful with, and this is the thing that a lot of people forget, is you need to define your variables. We have two different situations going on here. So I'm going to let X be the first bullseye. On the X shot. And I'm going to say Y is the number of bullseyes out of N shots. Okay? What kind of a distribution is going to use X? This guy is my geometric. What kind of a distribution will use Y? Binomial. So when I'm talking about geometric, my distribution will be geometric with P equal 0.8. When I'm talking about my binomial, I will have N equals something, P equals 0.8. Now, the first question said her first bullseye comes on the third arrow. Is that X or is that Y? X. What gives that away? What tells me geometric? One word should tell you. First. Right there. Her first bullseye is on the third arrow. So what I'm looking for here to write this properly, so this is 18A, we're going to say the probability that the first bullseye comes on the third arrow. Do you see how I wrote that? And I am perfectly happy with you using CalcSpeak at this point. These problems only. What type of distribution am I using? geometric. Am I going to use PDF or CDF? Pull the question back up. On a specific value. That's the PDF. You are going to use PDF whenever you see an equal to symbol. CDF is going to be less than or greater than. Okay? Geometric PDF, and your calculator will even kind of hint you off in the direction you should go with this. So I'm just going to see what it says I need. So geometric PDF, the first thing it asks for is the p-value, your probability. Then it asks for your x. So what is x here? 3. And I am fine with that for your work. I do want to see this. I do have to see your definition of your variables. So then I'm just going to do 0.8, 3, enter, enter. And that's what I get. Because basically what this just calculated is it said miss, miss, hit. Okay? X minus 1 goes here. 1 is here. Should still give you that same answer whichever way you go. Okay? All right. The next question says, she misses the bullseye at least once. What type of distribution is that? Not binary. I know where you're going with it. Close. Geometric is go until, looking for the first. So what was the other one? Binomial. Binary is yes or no. I knew you were going there. So for this, if I'm looking at that, wait a minute, at least once out of how many? 6. So here I've got n was 6. Okay, so for 18b, I'm going to say the probability, if we're looking at number of bullseyes out of n shots, that means I'm going to use the y, and it says at least once. What type of a symbol am I going to do for at least once? Less than or equal to 1? Greater than or equal to 1. Ugh. What is, remember, because this is saying that I can have 0, 1, 2, 3, all the way up to 6. That's the total number of bullseyes I could have. We're saying at least 1. Is 1 included in that? And am I going up or am I going down? Up. So which would you rather do? Calculate 1, 2, 3, 4, 5, and 6? Or is there something else you can do? 1 minus. So we're going to do the probability of that y, 1 minus the probability that y is equal to, this is what I'm cutting out, no, 0. The probability that I have no successes. Remember, the opposite of at least 1 is 1 minus the probability of none. So I'm going to turn this into 1 minus what type of distribution? Binomial. Binomial because we've got a set number of trials. PDF or CDF? PDF. And if I'm going through and writing this down, again, use your distribution to hint you as to what you need to write down. There's the binomial PDF. So trials, that means I'm going to put n equals how many trials? 6. What was p? 0.8. And what is x? 0. So if you want to write that, you can either write 6.4 times 10 to the negative fifth, or 1, 2, 3, 4, 6, 4. Yes.
So I got the same answer.
Oh, I didn't do 1 minus. I'm sorry. Thank you. That's where you were going with it, right? Sorry. I was going to say, that does not sound right. 999,936. There you go. Thank you very much. I didn't do the 1 minus to start off with, so make sure that you do that. And keep it so there's no glare there. Okay? How are we doing here? Meh. It's gonna take practice. So the first thing again that we did is we identified what all of my pieces are. We're making sure that we can actually use these models. You define your variables, then you do the sucker. That is not right.
Yeah. It's she hits the bullseye. I think you did if she misses the ball. She misses it once.
Oh, thank you. No, it's not CDF. The problem is I was using 0.8 as, wait, hang on.
6.85.
So you're doing that.
Oh, I see what you're saying. Yeah, there are multiple different ways. Okay. So going back to what I have drawn out over here, there are several different ways that you can do it. This is looking at the number of misses. So if I'm going to talk about the number of hits, because P is the probability of a hit, right? So if she misses at least once, then that means that we're talking about all of these guys. I don't know why I didn't just write 4. Shush. Show off. Okay. So then, yes, this would have been binom CDF. Thank you very much. Sorry for the confusion.
6.85 because you're hitting it 5 times.
Yeah, because there's the question set, and that's where it is. And the hardest part about this is really the reading of it. So if it says here she misses the bullseye at least once, but my 0.8 is that's the probability of hitting it. So you got to make sure that you're talking about it in the right frame of reference. So if she hits it if she misses at least once, then that means these are the possibilities for the number of hits I could have. And so since it starts at 0 and goes up to 5, that's CDF, you could do 1 minus binomial PDF of n equals 6, p equals 8, x equals 6, because that's what I'm crossing out. There's all sorts of different ones that you can do. Point, sorry, thank you.
You did binomial CDF. How'd you get x equals 5?
Because again, what the question was talking about is that you miss at least once. So it means it's not possible for you to have 6 hits. Okay? I know, that's going to be my hardest. It's your hardest part. Okay, guys, take a look at this next problem, please. We'll all try to get it right.
I still will not get this right.
Just relax, read it. Shh, guys, come on.
Wait, so you didn't have
So if I'm looking at C, is C a set number of trials or a go until? Go until. What gives you a hint that this is saying go until? First. The fact that you have the word first in there. So, according to what I had defined, am I going to be using X or Y here? X. Because I'm using the geometric way. For part C, we're saying the first is on the fourth or the fifth. In probability, what does or generally mean to do? Add. So I'm going to find the probability. We're again talking about the first. So I'm going to use X equals 4 plus the probability X equals 5. Is this geometric or binomial? Geometric. So I'm going to say geometric PDF, CDF, PDF because it's just one for each of them. PDF where P is 0.8, X is 4. PDF when P is 0.8, X is 5. So go ahead and see if you guys can calculate that. Yes, sir?
Okay, we just did 0.2 to the 4th times 0.8 and then 0.2 to...
Absolutely. If you would rather write out the equation, which is what you're talking about, so you're saying I am missing 3 and then I make... Oh, it's the other way around, yeah. I am missing 3 and then I make it. Plus I am missing 4, then I make it. Exactly the same thing. With geometric, it's almost easier to write the actual formula. For binomial, it's definitely easier to write it the other way. So what do you get? Very nice.
I really did it right.
Now, for part D, part D is saying she gets exactly 4 bullseyes. Is that geometric or binomial? Why?
4 out of 6.
Because we're saying exactly 4 out of 6. Is that going to be PDF or CDF? Exactly 4 is PDF. C is a range. Luke, you want to think about C as being continuous? There's a continuous range. This is just per for just one. Okay, give it a shot.
That's why you're yeah.
The problem with this is that there are a whole bunch of different ways to get exactly 4 successes. Maybe it's the first 4, maybe it's the last 4, maybe you lose the first and last, the second and the last, the third and the last. Too many things. You don't want to count them all. So the answer to this, they're using the mathematical formula, which is out of 6, choose 4 to be a success. Number of successes, number of failures. I would have just done it this way. You get the same answer. Please, please, please understand, PDF is a single outcome. CDF is a range of outcomes. It's continuous. Discrete versus continuous. That's what those mean. Okay? All right. Now, we are going to pick up with this next class because obviously we're pretty much running out of time. We have, ladies and gentlemen, we have covered all of the material that you are going to learn this year. Next class, all we're going to do is practice geometric and binomial. And then on Monday of next week, you all will have your quiz. After the quiz, we're just going to practice. And then on Wednesday, you're going to have your test.